We're surrounded by plastics, from the food we eat to the clothes we wear and even the furniture we sit on. Some of these plastics are so cleverly disguised that it's difficult to avoid them, especially when companies label them as eco-friendly. They may sound too good to be true, but that's exactly right. You might have seen products advertised as biodegradable and assumed they're harmless for the environment. But what if I told you that's not always the case? In this video, we'll dive deep into what biodegradable plastics are, how they affect our planet, and whether they're truly the sustainable alternative we believe them to be. So get ready to separate fact from fiction and discover why this seemingly green material can sometimes be anything but. When we talk about plastics, it's crucial to differentiate between two main categories: biodegradable and non-biodegradable. Non-biodegradable plastics are notorious for their durability. We are talking about those materials that can persist in the environment for hundreds or even thousands of years without breaking down. On the other hand, biodegradable plastics are designed to break down over time. But wait, don't pop the champagne just yet. Not all biodegradable plastics are created equal. Many of these materials need special conditions to degrade, such as high temperatures found in industrial composting facilities. Others require specific enzymes or microorganisms that may not be present in soil or water. Even under ideal conditions, some biodegradable plastics take months or years to decompose, which raises the question, are they really better than traditional plastics? Some plastics are labeled as biodegradable because they are made from renewable resources like cornstarch or vegetable oils instead of fossil fuels. But this doesn't necessarily mean they're more environmentally friendly. The production process for these bio-based plastics can be energy intensive and generate greenhouse gas emissions. Plus, growing crops for plastic production competes with food production, putting pressure on land and water resources. Even the disposal of these plastics can be problematic. If not properly sorted, they may end up in landfills where they won't break down as intended. But let's focus on plastics labeled as biodegradable because they meet certain criteria. For example, the ASTM International D640 standard defines biodegradable plastics as those that are capable of undergoing biological degradation under aerobic conditions resulting in the formation of carbon dioxide, water, and biomass. Sounds great, right? But this definition leaves some room for interpretation. What does biological degradation mean exactly? And what are these aerobic conditions? The ASTM standard also acknowledges that complete mineralization, where the plastic becomes part of the soil, might not occur due to factors like low temperatures or limited oxygen. While the exact degradation process varies depending on the type of plastic, here's a general overview. Under the right conditions, bacteria and fungi colonize the plastic surface. They secrete enzymes that break down the polymer chains into smaller molecules like sugars, amino acids, and fatty acids. These molecules are then metabolized by the microorganisms as food, effectively degrading the plastic. But as we mentioned earlier, these conditions are often not met in real-world scenarios. One common misconception is that once something is labeled biodegradable, it will naturally break down in soil or water. In reality, most biodegradable plastics still persist for years if thrown into regular trash or nature. For instance, polybutylene succinate or PBS, a biodegradable plastic used in single-use items like cutlery and food containers, can take 6 months to 18 years to degrade in a landfill. Even in ideal composting conditions, it may only take 90 days to 1 year. Similarly, polylactic acid, or PLA, commonly used for 3D printing and disposable cups, can last anywhere from 2 to 5 years in the soil. And if it's not composted properly, it may persist even longer. Now, you might be wondering why it takes so long for these plastics to break down. Well, several factors come into play. One major factor is the plastic's chemical structure. The longer and more complex the polymer chains, the harder it is for microorganisms to break them down. Another important factor is the environment itself. Conditions like temperature, moisture, and oxygen availability significantly affect the rate of degradation. For example, cold and dry environments may slow down or even stop the growth of microorganisms necessary for breaking down the plastics. Take, for instance, polyvinyl alcohol or PVA, often used in water-soluble packaging. When exposed to soil, PVA can take 7 to 14 years to degrade, but in a compost pile, it breaks down in less than 6 months. This highlights how crucial proper disposal is for biodegradable plastics. If they end up in landfills or the natural environment without the necessary conditions for breakdown, they can persist for years. You might think that biodegradable plastics are a win-win for the environment, but unfortunately, that's not always the case. One significant concern is the potential toxicity of these materials. Some biodegradable plastics are made from chemicals that can be harmful to the environment or human health. Take poly and perfluoroalkyl substances, or PFAS, often used in coatings for biodegradable plastics to make them water repellent. These chemicals are known to persist in the environment and have been linked to various health issues. Furthermore, the manufacturing process of these plastics may involve hazardous substances and generate pollutants, impacting air and water quality. As for their disposal, improper sorting or leakage into the environment can disrupt ecosystems, particularly when they end up in waterways and oceans. In marine environments, biodegradable plastics can still pose a threat to wildlife. A study published in 2019 found that fish were eating plastic labeled as biodegradable, mistaking it for food. These fish were part of the diet of many sea creatures, including seals and sea turtles, potentially causing harm to these animals. The ocean is a vast and complex ecosystem, and introducing foreign materials like plastics can have cascading effects on the delicate balance of life there. One major concern is the accumulation of plastic debris in the ocean's vast gyres, which are large systems of rotating currents. These areas, such as the infamous Great Pacific Garbage Patch, act as traps for floating debris, including plastic waste. Over time, these patches become highly concentrated zones of plastic accumulation. The detrimental effects of plastic pollution are widely documented, affecting marine organisms through entanglement, ingestion, and habitat destruction. Entanglement can lead to injuries, cuts, and abrasions, hindering movement, feeding, and breeding. Ingestion by marine animals can cause internal blockages, ruptures, and starvation. Additionally, plastic debris accumulates in the cells and tissues of organisms, potentially leading to bioaccumulation and biomagnification in the food chain. It can also destroy critical habitats like coral reefs, seagrass meadows, and mangrove forests, disrupting the ecosystem's balance. So while biodegradable plastics do break down in the ocean, they still pose risks during their degradation process, such as leaching harmful chemicals and microplastics into the water column, further contaminating the marine environment. The concept of biodegradable plastics seems promising, offering a potential solution to the plastic pollution crisis. However, it's essential to recognize their limitations and potential drawbacks. While they can break down in certain conditions, they may still persist for extended periods in landfills or the environment, posing risks to wildlife and ecosystems. Furthermore, the production and disposal processes should be carefully managed to minimize environmental impacts and prevent the release of harmful substances. Ultimately, reducing plastic consumption and embracing reusable alternatives remain the most effective strategies for mitigating plastic pollution and preserving our planet's health. The term compostable often gets mixed up with biodegradable, leading to confusion among consumers. However, there's a clear distinction between the two. Compostable plastics are designed to break down in a controlled composting environment, typically at industrial facilities or in home compost bins. They undergo a specific process where microorganisms break them down into organic matter, releasing carbon dioxide, water, and biomass. This process requires specific conditions, including controlled temperature and humidity levels, as well as regular mixing of the compost pile. On the other hand, biodegradable plastics, as discussed earlier, are designed to break down naturally in the environment, although this process can be slow and unpredictable. Not all biodegradable plastics are compostable, and not all compostable plastics are biodegradable. To ensure your plastics break down as intended, it is crucial to follow the manufacturer's disposal instructions and check for certification labels like the BIPI Biodegradable Products Institute certification for compostable plastics. Instead of relying solely on biodegradable or compostable plastics, it's essential to consider reusable alternatives. Opting for items like metal, glass, or ceramic reduces the demand for single-use plastics, lessening the burden on waste management systems and reducing the potential for plastic pollution. By choosing reusables, we can minimize the amount of plastic entering the waste stream and reduce the reliance on biodegradable or compostable plastics. Reusables like stainless steel water bottles, cloth shopping bags, and glass food containers are not only durable, but also contribute to a circular economy by reducing waste and resource consumption. When it comes to disposing of plastics, proper waste management and recycling play a vital role. If you're using biodegradable or compostable plastics, ensure they're disposed of in designated compost bins or facilities. If you're using traditional plastics, adhere to local recycling guidelines and sort your waste accordingly. Additionally, supporting policies and initiatives that promote plastic reduction, reuse, and responsible disposal is crucial. Encouraging extended producer responsibility schemes, where manufacturers are accountable for the entire life cycle of their products, can drive innovation in sustainable packaging and waste management. Plastic pollution poses a significant threat to our planet, and it's essential to critically evaluate the solutions we adopt. While biodegradable and compostable plastics may seem like a quick fix, it's crucial to understand their limitations and potential drawbacks. Embracing reusable items and supporting systemic changes in waste management and production are equally vital. By making informed choices and advocating for change, we can collectively work toward a cleaner, more sustainable future. As we wrap up this episode, we want to hear from you. What are your thoughts on biodegradable plastics? Do you find them useful, misleading, or have you had any experiences with them? Share your comments below and let's continue the conversation. And don't forget to like and share this video if you found it informative. Stay tuned for more engaging content on environmental science. Thanks for watching.